How to graph equations of the form y minus y1 is equal to m times the quantity x minus x1 by hand. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. So far we have graphed linear equations in standard form. A times x plus b times y equals c, using x-intercepts and y-intercepts. We have also graphed linear equations in slope-intercept form, equations of the form y equals mx plus b, using slope and y-intercept. There is another form called point-slope form. Before we use that form, we should see where it comes from. So point-slope form, and where does it come from? Let's say you're given the slope of a line, or represented with the letter or variable m, and a point on the line has some coordinate, some number, comma, some number, x sub 1, comma, y sub 1. We also will need the variables x and y in the equation as well. Let's begin with what slope means. Slope, you can think of as rise over run, change in y divided by change in x. Subtract the y's over subtract the x's in the same order. So with m being the slope and a point x sub 1, y sub 1, let's let the coordinates of a second point on the line be represented as x comma y. There's where we'll get our x and y into the equation. So here's our slope formula. We're going to go ahead and substitute, but in place of x sub 2 and y sub 2, we're going to put x in place of x sub 2, plain y in place of y sub 2. We'll put in the m for m, and we'll leave x sub 1 and y sub 1 alone. We know those will be supplied to us. So here's what we get. M is equal to y minus y sub 1, replacing this with y, over x minus x sub 1, replacing this with x. We're going to multiply each side by the denominator so that we can clear out the fractions. So we're going to multiply each side by the quantity of x minus x sub 1. And when we do that, the left side becomes this. The right side, the numerator and denominator, make a 1, so we're left with y minus y sub 1. And I'm just going to switch sides using the symmetric property to rewrite it. And we'll get y minus y sub 1 equals m times the quantity x minus x sub 1. And this is it. This equation is in what we call point-slope form, where m is the slope, x sub 1 comma y sub 1 is the point that the line goes through. Press pause as needed anytime. Let's look at some examples. So here's the first example. We want to graph y minus 2 equals 3 times the quantity x minus 1. Notice it's not in standard form, it's not in slope-intercept form, but it is in what we call point-slope form. So I'm going to write the general equation that we just generated in point-slope form below this equation. Y minus y subscript 1 equals m times the quantity x minus x subscript 1. You can see the similarities for sure. We can now identify the three values for x sub 1, y sub 1, and slope. Pause to do that. Resume when you're ready. All right, so I've found y sub 1 to be positive 2, m to be positive 3, and x sub 1 to be positive 1. We'll go ahead and write those down right here. And from these two, we get the point. 1 comma 2 is a point on the graph, and we can go ahead and plot that point over 1, right 1, up 2. So 1 comma 2 is a point on this line. And now we can use the slope 3 to plot at least 2 more points on the line. So go ahead and pause as needed. Resume when you're ready. So I can think of 3 as positive 3 divided by 1. So the change in y is positive 3. The change in x is positive 1, which means from here I go up 3 and to the right positive 1. And there's a point on the line. I can also think of the 3 as negative 3 divided by negative 1, which would mean go down 3, negative 3, and to the left 1. And so those 3 points are collinear, and we connect them into the line. Go ahead and pause as needed. Second example, we want to graph y minus 4 equals negative 1/2 times the quantity of x plus 3. Again, we write the general equation below this one. But before we do that, we need to rewrite the quantity of x plus 3 because it's not as a difference. We needed to write it as an equivalent difference, as a subtraction expression. And that would be the quantity of x minus negative 3. Those two forms, or those two expressions, are equivalent forms. Now that we've rewritten it, we can now identify the values for x sub 1, y sub 1, and m. So go ahead and do that. Resume when you're ready. And so it looks like y sub 1 is positive 4, m is negative 1/2, and x sub 1 is negative 3, minus a negative 3 here. So we can go ahead and see that this is a point on the graph. Negative 3, up 4. And we can use the slope to plot at least 2 more points on the line. So pause is needed. Resume when you're ready, when you have those points plotted. So I can think of negative 1/2 as negative 1 divided by positive 2, which would mean down 1, right 2, down 1, right 2, and there's a point. I could also think of negative 1/2 as positive 1 divided by negative 2, so that would be up 1, left 2. And you can see that those 3 points are collinear. Draw the line, and it has a slope of negative 1/2, sloping downhill from left to right, and goes through the point negative 3, 4. Pause is needed. Resume when you're ready. Third example, we need to write the general equation in point form below this equation, but first we're going to have to rewrite this equation to have differences. So go ahead and pause as needed. Resume when you have those rewritten as differences. So I'm going to rewrite y plus 2 as y minus negative 2, and 3/5 times the quantity x minus 0, so that I have a placeholder for x sub 1. Make sure that they're equivalent differences, not just differences. They have to mean the same thing. So now identify the 3 values. Pause is needed. Resume when you're ready. And it turns out that y sub 1 is negative 2. The slope is positive 3/5, and x sub 1 is 0. Go ahead and draw the line. Pause is needed. Resume when you're ready. So 0, negative 2 is the point. Turns out to be our y-intercept, in fact, 0, negative 2. The slope, we can find at least 2 more points. If you haven't done that already, please use 3/5 to find at least 2 more points. Resume when you're ready. So 3/5, I can go up 3, right 5, and there's a point. I could also think of 3/5 as negative 3 divided by negative 5, which would be down 3, left 5. Plot the point. The 3 points are collinear and we can draw the line. Pause is needed. Resume when you're ready. Now you try some. Graph this equation, y plus 3 equals the opposite of the quantity x plus 4. I'm just going to show you the answer, so go ahead and finish this problem. Resume when you're ready. I had to rewrite this as y minus negative 3 equals a negative 1, so I have a number for the slope. And I had to rewrite this as x minus a negative 4. Here are the three values that we got for x sub 1, y sub 1, and m, the slope. I plotted the point in negative 4, negative 3. And I used the slope down 1, right 1 here, or up 1, left 1 for this way to rewrite negative 1. And there's our line. Pause is needed. Resume when you're ready. Now try one more. Graph y equals 3 halves times the quantity x minus 4. Again, almost showing the answer there on the next one, so take your time. Resume when you're finished. Rewriting is a difference, y minus 0. So y1 is 0, m is 3 halves, x sub 1 is positive 4. The point is 4, 0 right here, an x-intercept if you will. The slope is 3 halves, which means up 3, right 2 from here, up 3, right 2. Or I could think of it as negative 3 divided by negative 2, which is down 3, left 2. 3 points are collinear. We've got the point.